Hey guys, so I'm here to talk about a concept that is very important to calculus. It's called limits. What is a limit? A limit is when you talk about a limit literally, you definitely think about probably the amount of weight something can withstand. And with that example, let's say we have a table that was built to withstand 10 pounds. So the limit of this table is 10 pounds, correct? So let's say you had weights of a pound each in 10 places, and you stack them on here, one on top of the other. The closer you get to stacking 10 of these weights, the closer this table is to break-in. So we can infer that the limit of this table is 10 pounds. Now, if we're trying to shift closer to the concept of limits mathematically, it is a little bit more in-depth than what we just discussed. So now, let's take a look at the graph, or a linear graph. Let's start it slow. The linear graph of f of x equals x plus 2. I already did that. It's right here. So that's the graph of f of x equals x plus 2. X plus 2. So now, if we were asked to find the limit of this line as the value of x approaches 2, this is when the value of x is 2. So first of all, you start from the line. You could either go in from the left hand side or the right hand side. It really doesn't matter as long as you hit it on 2, and it doesn't matter except if it's specified what side to go on. And as we discuss this further, we'll actually talk about left and right hand side limits. Anyway, so we are trying to find the limits of this line as x approaches a value of 2. So this is the graph. We're coming in from here. We're going in, and at this point on the graph, the value of x is 2. At this point where x is 2, what is the value of y? That is one way to put it. At this point where x is 2, y is 4. So the limit of this graph as x approaches 2 is 4. But we can just write that statement in a sentence. That wouldn't be accurate. We could just express that mathematically as the limit as x approaches 2 of f of x. And we know that f of x is equal to x plus 2, which is this line, is equal to 4. This statement. It might be confusing at first, but it is pretty easy to understand how to express your limits in this format. What you do is you see the LIN, that obviously stands for limits. Then you put your f of x, which stands for the equation. Your x, this arrow is a symbolic way of telling you what value the x is approaching. And in this question, x was approaching 2, so the limit of f of x as x approaches 2 equals 4. Now there is a last thing I have to tell you about. So most times there will be a superscript, either positive or negative, a superscript for the value of what x is approaching. Now what that is telling you is what part of the graph the limit enters from. Like if you're coming in from the right hand side, you have a positive superscript. If you're coming in from the left hand side, you have a positive superscript. And the importance of this superscript is sometimes you might have a different left hand side limit and a different right hand side limit. So this superscript actually helps you to determine what value your limit is depending on what side you're entering the graph from. Now let's take a look at another graph. Let's see here. Let's look at this graph. This is the graph of f of x equals 1 over x. Now we just talked about left and right hand side limits having different values. Well, this is a perfect example of that situation. Now coming in from the right hand side, the limit, let's take this step by step as x approaches. Let's see, we should use x approaches 0 here. Let's take negative. What does that negative superscript tell you? I just said it tells you what direction you're coming into the graph from. So it's a negative superscript this time, so meaning we're coming in from the left hand side. So coming in from the left hand side, what value does, well, as x approaches 0, what is the value of y? So coming in from the left, x approaches 0. So this is, at this point, x is 0, okay? So x is approaching 0, x is approaching 0, x approaches 0. Yeah, so at this point, x is 0. What is the value of y? We see that this graph, the graph approaches infinity, because at this point it just keeps on going in a straight line, it doesn't really stop. So the limit as x approaches 0 from the negative side for f of x is equal to negative infinity, because, well, this is negative infinity, this is positive infinity. I'm sure you know that because they can't both be infinities. So the limit as x approaches 0 from the positive side, from the right hand side this time, for f of x. Coming from the right hand side, you hit this graph first, not this graph. You can't come in from the right hand side and skip this part of the graph and just come straight here and say it's negative infinity. That would be totally wrong. So this is the first part of the graph you hit. So you come in here, x is approaching 0, x is approaching 0, and this is where x is 0. So here it's positive infinity. So from this value we can tell that the limit as x approaches 0 from the negative side is not equal to the limit as x approaches 0 from the positive side, which leads us to another term called well, at this point, in a situation like this, what you say is the limit is undefined, or there is no limit at x equals 0, because both the limits have to be the same for a limit to exist. Both limits from both sides has to be the same for the limit to exist. Okay. So to express this, you could just say limit as x approaches 0 from the positive side for f of x is not equal to the limit as x approaches 0 from the negative side for f of x. So here, if you had a question that asked you if the limits existed, your answer would be no, because both left and right hand sides of the limit are not equal to each other. So another way to determine, so that's how to determine if a limit exists or not, or if it's defined at a certain point or not. Now, you could definitely evaluate limits from its graph, but another way to evaluate limits is doing it algebraically. So take, for example, this limit. You're given the limit as x approaches, limit as x approaches 2 for f of x. Now when you're solving algebraically, you don't necessarily have to put the superscript, because it doesn't matter what part you're coming in from. All that matters is solving the algebraic expression. You have f of x equals x squared minus 1. What you just do is you substitute the value of x equal into the equation. So here our x is 2, so we have 2 squared minus 1, which is 4 minus 1, which gives us 3. So the limit as x approaches 2 for f of x equals 3. Now there's a special situation where you have to be careful. When you have a question that gives you, let's take this away real quick, the limit as x approaches 4 for x squared minus 16 over x minus 4. You could just switch in the x with the 4, and you have 4 squared minus 16 over 4 minus 4, which would give you 16 over 16 over 0, which would be 0 over 0. That's undefined, which is great, because the limits can be undefined. But in this situation, you have to evaluate the equation first before you substitute the values. So we have x minus 16 over x minus 4. You could easily say this is x squared minus 4 squared over x minus 4. We can definitely use difference of two squares, x minus 4, x plus 4 over x minus 4. This would cancel out. You'd have x plus 4 left. When you substitute the value of 4 into the equation, you have 4 plus 4, which is 8. So the limit as x approaches 4 for x squared minus 16 over x minus 4 would be equal to 8. There you go. So it might not be easy right now, but with practice it gets easier, and your future calculus solving person would definitely thank you. So yeah, just practice it and you definitely get the hang of it. Bye guys.